Thank you for introduction. So in this talk, I'd like to talk about derivation of optimal delivery route in logistics using quantum computer. This is a joint work with QCware. Here is the outline of today's talk. First of all, I'd like to explain background. Secondly, the reason why Aisin is developing quantum computing. Thirdly, I'd like to explain Aisin's vehicle routing problem. Finally, I will give conclusions. I'd like to explain the reason why Aisin is developing quantum computing. The first reason is quick response for market needs. Second reason is realization of carbon neutral society. This is what Aisin specializes. On the left is our current product. We have powertrains such as automatic transmission, hybrid system, manual transmission. And we have door parts, GPS, and logistics support system. In addition, we have energy management system, such as fuel cell for house. On the right is our future product. This figure shows our products change drastically. To do this, product efficiency and reduction of development time are important factors. Therefore, we are developing optimization method and machine learning method for big data analysis using quantum computer. I'd like to explain the effort of quantum computing in Aisin. We have 3 items. Firstly, we are developing specific application using quantum computer. In this talk, I'd like to talk about logistic efficiency by using quantum computer. Secondly, we are exploring quantum computer for specific application. We are exploring what is the best quantum computer to solve our problem. Now we can use superconductive trapped ion. In addition, we are researching for photonics type quantum computer and neutral atom computer. In Aisin group have optical technology. We are researching the application of our optical technology for quantum computer hardware. We have 4 items regarding optical technology. We have integration of optics, phase control, noise control, and signal modulation. In 2020, we announced we started to research quantum computing with QCware. In 2022, we announced the digital transformation in logistics. In this web page, we introduced our result by using quantum computer. I'd like to explain Aisin's vehicle routing problem. As a specific example of quantum computing, we are considering about the vehicle routing problem. Vehicle routing problem is typical example of combinatorial optimization problem. Computational optimization problem is large scale size problem. So this figure shows the concept of digital transformation in Aisin. The main purpose of us is human-friendly logistics. We have 4 projects. Today, we will focus on project 2, the visualization of delivery and visualization of optimization of delivery routes. So in this talk, we will focus on from logistics center and warehouse and plant. This figure shows a roadmap of Aisin's logistics optimization using quantum computer. Current status. So we are using human expert knowledge. So that is based on experience and instinct. In addition, we are using classical computer. As the midterm objective, we are developing vehicle routing problem by using NISQ-ERAS quantum computer. As the long-term objective, we can use fault-tolerant quantum computer. We believe that we can solve supply chain management. We are working on this project for fault-tolerant quantum computer in the future. I'd like to explain the detail of Aisin's vehicle routing problem. So our main purpose is to optimize the truck route and to minimize total number of trucks. We have approximately 200 suppliers. The parts are collected to logistics center and delivered to plant through the warehouse. Here, our target is powertrain plants. We can manage the routes and trucks in the blue box. The total number of parts is approximately 16,000. The total number of the boxes are 35, sorry, 35,000. Sorry, I'm Japanese, so sometimes I'm confusing. And the weight is 3,800 tons every single day. So we have 23 sites, 1 logistics center, 1 warehouse, and 11 plants. The total number of delivery routes is 23 factorial. This is large-scale size combinatorial optimization problem. Therefore, we decided to use quantum computer. To solve our problem, we used real-world data in logistics. We used address of logistics center, warehouse, plant, daily delivery information of the parts, and the driving time between the sites. Furthermore, we use truck information such as capacity, operation hour, and parking time. We have constraints of the delivery routes. This figure shows the result using quantum computer. On the left is current status by expert knowledge. The Nishio Logistics Center is the largest logistics center. Human experts set up this largest logistics center as the center of logistics. On the right is the result using quantum annealing. Unlike the human expert, quantum annealing connects the sites that far from each other. So our method is hybrid quantum and classical computer. This is output of the quantum annealing. We have total number of tracks and optimal delivery route. By using classical computer, we can compute the time of arrival, location, loading and unloading boxes for each tracks. We can calculate total driving time for each tracks. Furthermore, we can calculate the loaded volumes for each tracks. I will give conclusions. We succeeded to optimize the optimal track routes and to minimize total number of tracks. So now we are developing to solve same problem by using gate-based quantum computer. So, thank you for your patience.
Yeah, I had a question about flexibility. So as we've seen in the last few years, supply chains can get disrupted. Yeah. It's very difficult to adjust to that. So how much flexibility do you expect to accommodate in your system using these computing methods?
Yeah, that's a good question. So now I am using the quantum annealing. So we have the suspicion about the fidelity of the quantum computer. So now I cannot rely on this result. So therefore, we are developing the methodology by using gate-based quantum computer.